I'll spend most of the time talking about mixed models analysis. So if you want to analyse all the data together, this is really the way to go because it can cope with missing data, and it's also appropriate, when data are not missing too. So it's always a suitable method to analyse the data. And it will automatically give, I've put treatment effects here, but any sort of group, whether it's different genotypes, whatever you're comparing, they're always going to be compared against the correct unit of variation. They'll have suitable standard errors. The significance tests will also be appropriate. You can get treatment effects at each of the time points, and the standard errors and the treatment effects or the group effects are going to be based on information using all time points. So if you've got some missing data, it'll take into account for that unit what the other time points the value was and estimate. Effectively, it's kind of imputing information from the other time points to get that missing value and to provide an appropriate estimate. The other thing that's possible in mixed models is you can take into account the patterns of correlations occurring between the repeated measurements. So it might be that you don't want just to say there's a constant correlation, some kind of correlation. You might say that the measurements closer together are more correlated than other measurements. And I'll spend a bit of time in a minute looking at what this means and the different patterns that it's possible to set up. So there's actually different ways or different types of mixed models that can be used to analyse repeated measures data. A very simple approach is to just fit, I've put patients here, but if you can imagine instead of patients, that's just the individual or unit you're repeating on. So it might be the sample, it might be an animal, but I'll talk in terms of patients at the moment. So you can just fit patient effects as random. That is sufficient, but it does have the effect of saying we've got some kind of correlation between the patients and we're treating it as a constant correlation, but of course it might be a bit more complicated than that. It might not simply be a constant correlation across the time points. So that's where something called covariance pattern models comes in, where you can fit a pattern of correlations over time for observations on the same patient or unit. And a completely different approach, which is still a mixed model, which may be useful if you're more interested in the relationship over time rather than analysing individual time points, is the random, what I've called a random coefficients, or sometimes it's called a random slopes model, and that concentrates on allowing regression slopes or even curves to vary randomly between the patients or the units. So we'll look at those a bit. So that offers an alternative approach to analysis.